Hi,
Yeah, hi guys, how are you?
I'm good, Anjan. How about you?
Yes, I'm pretty much cool. And thanks for asking me. And so I'm just continuing our previous session. So what the last class? So the last class is that, any data science project, it could be starts with, you know, exploratory data analysis, right? So from that one, while we are doing EDA process, so we do have various steps are there.
Are there?
So yes,
Four types. Four types.
please
So in
mute
the
your systems. Okay. So we do have various steps are there while we are doing the EDA. Okay. So from that one, the first step is that we need to go for understanding the data. By the time of understanding the data, first thing is that we need to read the data set from where, the location where we have it from that particular location. We need to read the data with the help of that specific API. So if you're reading that CSV file, then we can use the read underscore CSV. If you're reading Excel files, then we can use the read underscore Excel. And if you're reading the Parquet file, then we can use the read underscore Parquet. Okay. So the corresponding extension of the file, then we have to go for use the corresponding function or else method or else API of the pandas. Clear? Yeah. So that it could be the first step. Okay. So reading the data set. Okay. Second one is that, I want to know that each and every column or else each and every feature, what could be the data type. Okay. So here we have approximately 23 columns are there. So some of the columns are integer, some of the columns are object. So object indicating that it could be the categorical type, and integer and float, it could be the number type. Okay. So I already explained you. So we do have a two type of data types. One is the quantitative and one is the qualitative. So here integer and float, it could be the quantitative, and object, it could be the type of the qualitative, right? So with help of the shape, we can see that a dimension and how many number of observations. That means records. We can call it as the records or else rows. Okay, we can call it as the records or else rows. Okay, and observations. Generally, we can call it as the observations, records or else rows. Okay, there are 40,000 observations are there. Okay. So here 23 indicating that features, 23 features, we can call it as the features or else variables or else columns. Clear? Yeah. So here, so head is the method. It could help you to return the topmost. So the first records, topmost records are the first records. Okay. So by default, it can be returns the 5. If you want to read the first 10 observations, then we can just give the count of 10, then which means that which is reading the 10 first observations. Okay. If you're not giving anything, then it could be considering the 5. Clear?
yeah.
Yeah,
Yep. Tail is the method. It could be written the last 5 records, top 5, no, bottom 5 records. If I'm giving the a tail of 10, then it could be returns the no a bottom 10 records. Okay. Yep. So with help of the is now method, it could help you is in my data set. Is there any data has been missed or not? Okay. If you want to know, then we can use the is now method. Okay, is now, and then sum is the function. It could be written the each and every column, how many number of null values are there. Okay, how many number of null values are there in each and every feature. So for this particular data set, so you don't have any kind of missing data. Okay, so in some situations, if we have a missing data, so it's our responsibility. You need to handle it. That is the step. It comes under the case of feature engineering. Clear, right? in EDA, we are just understanding, we are just analyzing, okay, in terms of missing values, we are just finding is there any kind of missing values are there or not. If we have missing values, the approach of handling, the approach of handling the missing values, it comes under the feature engineering step. So far, we are not stepping into the feature engineering. If and only if we completing the EDA step, then only we can move forward to the feature engineering step. Okay. In case of feature engineering, so you need to handle if you have any kind of missing values. Okay. So by God grace, in this particular data set, you don't have any kind of missing value. But in general scenario, in real-time scenario, you might have missing values. So for handling the missing value, what are the methodologies are there, and so how we can handle it, that we will talk in the case of the feature engineering. Clear? Or any questions? Generally, for handling the missing value at PE means feature engineering step. Okay. So if we have any kind of missing values, then we have one method is remove. Remove is the one option, but is not a good idea for at all. Okay. Some scenarios it could fine, but some scenarios it is not fine. Okay. Removing the missing values is not the solution for handling the missing. That is the one approach. Second one is imputation. Imputation means wherever the missing values are there, okay, with the help of the k-means clustering, I mean, different methodologies are there. Okay, k nearest neighbors, or else so someone is missing. Are we using all Python libraries here? Yes, Tanya, we are using Python libraries here.
Okay.
Yeah. So here for handling the missing values, we have two options. One is removing, and second one is imputation. So while coming to the imputation, we have again various approaches are there. Okay, one is we can impute replacement with mean value, or else we can replacement with mode, or else we can replace with median. That means central values, or else with help of the KNN or K means, okay, KNN or K means K nearest values. Okay, so with help of other machine learning algorithms, we can impute the correct value. That means we are going to be predicting what could be the missing value, and that value only we are replacing it. That is the best option. Okay. And simply in a general scenario, okay, if that is it's a pretty important question actually. So when you're attending the interview, okay, so the interview could ask a question, how you can handle the missing value. So generic answer is that simply people are saying that if you have any kind of missing value in my data set, simply I can remove it. That is not the solution. That is not a correct answer. Okay. Yes, of course, we can remove it, but that is not the final option. That is not the first option. Okay. And that is not a correct option also. That is the one step. That is the one method. That's it. Okay. So imputation is also another option for us. And even in imputation also, we have various methodologies are there. Either we can use mean. Okay, that means, for example, if your variable is the numerical type, okay, if the data it was normally distributed, then the imputation is different. If the data is not normally distributed, it could be uniformly distributed, then different approach. Okay, if the data it could be categorical type, then different approach. Okay, if your feature so with help of various machine learning algorithms, we can predict the what could be the missing value. Okay, then that value only we can replace it. Clear, right? I need answer from your end. Is that answer, did you get it or not?
Yes,
Okay.
I'm good.
See, generally this things I don't want to explain in detail, but thing is that you guys are facing an issue in a time of interview, so that I'm going little bit of in depth. So try to observe and try to grasp it at least. Okay. Fine. In the second step is descriptive statistics. So far, even we just find the missing value, but we not at all handle it so far. Okay, of course, how we can handle it, I can explain, future engineering step. And this time you just get this some kind of idea. Okay, so if you have any kind of missing value, so we need to go for handle it. Without handling, don't go for the machine learning, building the machine learning model. Okay. Yep. So the second step is that make sure that we need to do some kind of descriptive statistics. Descriptive statistics, it could help you to describe your data. Okay, how your data it has been distributed. So what could be the central point? How data it was, spread. Okay. So with help of various techniques, with help of the central tendency, with help of measure of central tendency, we can calculating the, so what could be the middle term? What could be the center value? So which means that around the center, the data it has been distributed. Okay. Clear? Let me consider. So you have a data point something like this. So this is my x value, this is my x variable, and this is my y variable. Okay. And I would like to tell that, this is my, okay, so this is my data. So this is my data points. So how can you say that? Most of the data it has been distributed with around the mean or not. So this is the central tendency. The central tendency, generally we can calculate it with help of the mean, median, mode, but we have other approaches are there, harmonic mean, okay, and trimmed mean, different things are there, okay. But most of the time, mean, median, mode is the generic methodologies to calculating the central point. Not only that one, we might have the trimmed mean, harmonic mean, okay. Yep. Any questions? So calculating the how the data it has been distributed. For example, in my previous example only, so the data it has been spread around the mean, right? And how the data it has been spread around the mean, that we can calculate it, that we can observe with help of various methods, with help of the range method, variance method, standard deviation method, quartile method, interquartile range. So these are the different approaches, different methodologies. With help of this methodologies or functions or concepts, we can calculating the how data it has been spread around the mean. And for example, if your variable is the categorical type, then how you can calculating that, with help of the frequency. Frequency means, most how many times each and every observation it has been, repeated, so that we can call it as the frequency. So generally we can call it as the mode. Mode means maximum time, maximum frequency count, that we are calling it some mode in case of categorical variable. So this is the three things we do on data, based on data only. If it is the quantitative, then this is the two things are supported. If it is the qualitative, then frequency count, it could be the option for us to understanding the data in a description formation, like to describe about your data. So based upon your data type only, we can do that. If it is the numerical, then this is the two approaches. If it is the categorical or object, then third one. Okay. Yep. So you already know that what exactly the discrete and continuous, nominal and ordinal. So with help of the describe method, if I'm giving the exclude equal to object, that means we are just accessing only integer and a float type of data only. So that which means that we are excluding, right? Excluding means object, except object. I mean categorical. What other data types we have it? So that data types description we are finding actually. Okay. So it could be returns the mean. Mean means average, and the standard deviation means it's the square root of the variance. Variance means the distance between the mean and the new data point, that we are calling it the residual distance. For residual distance, we have to do the square term, that we are calling it the variance. The value of the variance, if you do that square root, that we are calling it the standard deviation. And this mean, min, max, that means what the data we have it, that data we are describing with the 5 elements: mean, min, max, 50 percentile, 25 percentile, and 70 percentile. Okay. So with the help of the describe include objects, so this it could be returns the only count and unique. So how many times, how many unique observations we have it, and from that one, which one is the toppest one? Okay, how many times the toppest one has been repeated? So that kind of table it can be generated with help of the describe method when your features are object type. So in our data set, these are the variables are the categorical type, and these are the variables are the integer and float type. Okay, so this is about descriptive statistics. Any questions, guys, regarding about descriptive statistics? I explained, right? Hello? Any question?
No, no.
No.
Just 1 second. Yeah. What is the next step? Data cleaning. In EDA, and this data cleaning, it's a part of the data engineering as well. Okay, so feature engineering. Data cleaning is the step which is repeated in a data engineering, sorry, feature engineering. Okay, but so the first thing is that so previously we seen that identifying the missing values and we need to handle it. So first we need to identify the missing values and we need to handle it, right? Okay, and how we can able to identify, so that you already know it. Okay, so data dot is now of sum. Okay, so identifying the missing values. Identifying the missing values. Okay, so here we don't have any kind of missing value, so that is your analysis from this one. Okay, and next one is detect the outliers. First we'll detect these all things, then we can handle it. So detect the outliers. What is outliers, guys? Missing values means some null value. So when you're, it's a data entry or data collection, it could be the manual or it could be machine generated data, right? So by the time maybe that particular situation, people might forgot to enter the data, or else machine can mislead some kind of thing, or else it could be it could be enter some mislead data. So that kind of things we can call it as the
Missing
missing
is correct
values.
data.
Now I'm talking about outliers. What is outlier?
Missing or incorrect data.
No, missing is missing. Missing means what? Incorrect data, or else maybe you're not enter the data. That we are calling it's a missing data. Outlier is different. Missing means it's a wrong information.
They are the
Missing.
values within a data set that vary greatly from the other ones. So they can be
Yeah.
either
So,
smaller or larger.
so there could be a small variation is there, missing values and outliers. Missing values means incorrect data, inconsistency data. Okay. It is not valid data. So that we are calling it's a missing data. Outliers means it's a valid data. It is a valid data. It is correct data. But the thing is that it could be a little different. What exactly it is? Let me take it. I have X variable, and so most of the data it was distributed here. So this is my data points, and here approximately, and so 1 lakh of observations are there. Okay, and here same some more X values are there. Here it could be something like 5 or 10. Okay. Yeah. Okay, so most of the data it could be distributed here. Okay, some of the data it was in somewhere else. Okay, like some here. Okay, so these are all, it could be one group, but some of the points it could be with some distance somewhere else, right? So this is the points we can call it as the outliers. Outlier means the distance between your central tendency and your values, it could be too far. But sir, even this value is also, it could be right, it could be far only, right? Okay, but thing is that even most of the values are with this distance only. Okay, here also you might have it, here also you might have it, here also you might have some points. So most of the values, it could be equal distances, the distance between the central point and the data point. If it is some same values or no near values, so that is not outliers. But some of the points, it could be too far. Those values, those points, those data points, we can call it as the outliers. Clear? Let me take some example. You have a bank account. You are using the US banking. Okay. And every month your transaction is $5,000. Okay. Total transaction every month it's a 5,000. That means in between 4,000 to 5,000. It is not less than the 4, it is not less than the 5. Okay. 1 month, unfortunately, 1 month it up 40,000 transactions in overall, okay, transaction in a single month. Generally, the average or else the range of the transactions in every month, it could be 4,000 to 5,000. Unfortunately, this month and the previous month, okay, so the the transaction, it could be a 1 lakh dollars or else $1,50,000 in a single month. Okay, second month it could be up, again 4,000. So that 1,50,000 transaction is a very big number when you're comparing with every month transaction. That values we can call it as the outlier. Is it missing data? Is it any inconsistent data? You only did the transaction, right? Yes or no? That's your account only, right? The transaction is happened through your bank account only, right? So that's the real data only, right? Yes or no?
Yes.
But the distance, it could be very far. So every month the transaction, that means the average of the every month transaction and today's this month transaction, it could be too far. So that kind of data points, we can call it as the outliers. Okay. So outliers means what? Data points are too far with central tendency. Okay, how you can able to calculate it, how you can detect it. Okay, for detection of outliers, there we have various options are there. One is the phi summary data. Phi summary data, okay, or else interquartile range. So from the phi summary data only we can calculate the interquartile range. Okay, interquartile range. So for that one, plus or minus, okay, plus or minus 1.5 into, so sorry, phi summary data. Second one is the box plot. With help of the usual techniques, box plots or else whisker plots, okay, or else distribution plots. So this outlier checking, again we have various options. With help of the visualization techniques and with help of the normal statistical approach, we can calculating the is there any outliers are there in your data sets or not. Okay, visual techniques and non-usual techniques, graphical technique and non-graphical techniques. That is the two approaches we can handle the, or we can detect the, we are not handling, we are detecting the outliers. Okay, so how you can, how you can able to calculating the how you can detect the outliers in a phi summary data. So in phi summary data, you know that Q0, Q1, Q2, Q3, Q4. So you can representing your data with the 5 elements. Okay. So Q0 means min, Q4 means max, Q1 means 20 percentile data, Q3 means 70 percentile data, Q2 means it's a median value. Okay. So now we have to go for calculating the IQR. IQR means interquartile range. So Q3 minus Q1 that we are calling it's the interquartile range. Okay.
I engine.
Yeah. Just 1 second.
Okay.
Yeah. So I just want to tell you that, so various methods, right? So what are the methods to detect the outliers? So the first one is the statistical tests. Statistical tests. Okay. So second one is visual techniques. So here I'm writing neatly. So hope you can understood. So this is also interview question. And with help of various machine learning algorithms. Okay. and with the help of like domain specific methods, robust statistical methods, median absolute deviation, and multi-dimensional outlier detection. So okay, so I'm writing all the steps. Domain specific methods. Next, statistical metrics. And multi-dimensional outlier detection. Okay, cool. So in the statistical texts, so again we have two options are there. Let me convert into Markdown. Okay, so in a statistical tests, again we have two options or two methods. One is what? Z-score. Okay, second approach is interquartile score, IQR. That only we can call it as the interquartile range. Okay, score. So this is the two things we can call it as it statistical tests. Okay, so first we'll see that, first we'll see the Z-score, and then we can check with interquartile range. So just copy this one. Comment. So Z-score. What is Z-score? Anybody can you tell me what is Z-score? I think this Z-score formula you already know that in your child world. So for example, this is my data point. So this is my data. Okay, this is my X data. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 5 and this is 6, this is 7, this is 8, this is 9, this is 10, and this is 100. Okay, this is 200, this is 500, and this is 1 lakh, or else 10,000. Okay, see, 5, 6, 7, 8, 9, 10, 20, 30, 40, 5,000. Okay, so I want to find the outliers. So this position is 1, this position is 2, this position is 3, this position is 4, 5, 6, 7, 8, 9, 10. There are 10 elements. Okay, so the Z-score is X mean minus, so absolute value of X. Absolute means it's X mean minus X I, okay, by standard deviation. This is mean, guys. You already know that how we can calculate the mean. So sum of all elements by total number of elements, we can call it as the mean, right? And xi in the sense, so this is the value. So first element, and then second element, then third element, then fourth element, fifth element, something like that. Okay. So that we are calling it the xi. For example, this 5 is the outlier or not. If I want to know that, then we can replace xi by the 5. And this means average of this one. Standard deviation also, you know how we can calculate it with help of standard deviation. That means sum of x mean minus xi whole square by, no, you already know the formula for the standard deviation. So this way we can calculate the every time Z score. So that Z score value, if it is the, we are doing absolute value, right? So that if it is the more than 3, then that value we can call it as the Z score value if it is more than the 3, because we are doing absolute. If it is not absolute, less than the -3 or greater than, or less than -3. So if any value, if any Z score value, if it is more than the 3, or else if it is less than the -3, then that Z score value, that corresponding value, we are calling it the outlier. Okay. Clear, right? Let's take some
Yes.
example, guys. Yeah, let's take some example. So I'm just creating the one array. So import you already imported, right? Okay. So let me take some example. Data dot amt. So this is your your amount variable. Okay. So I want to find is there any outliers are there in this particular amount variable? Okay. This is my x. Let me consider this is my x variable. Okay. We are taking the amount variable or amount feature. I want to find the outlier. Is there any outliers are there or not? So you're taking the x. Then what is the Z score? What is the Z score formula? What is the Z score formula? Mean minus a variable. Okay. And by standard deviation, right? NP dot ABS. If I'm giving ABS, then it's absolute value. Okay. ABS X mean, right? So X mean minus X by DF. It's not DF, X dot STD, standard deviation. Okay. This is your Z score. So I want to print the outliers. I want to find the outliers. The outliers are, so where your Z score values are greater than your Z score is greater than the 3, those variables we can call it as the outliers. Simply we can print the outliers. So here outliers are not single values, it may be multiple values, so that outliers. Hmm? It is series. Okay, now it's correct. Actually, it's a series. Okay, so that we need to be converting into the array. Okay. Yeah. Built-in function method, unsupported file operands, service. Oh, clear. Built-in functions or methods. In minus x by x std. Fine, sorry, I made a mistake. It's a function. Yeah, just 1 second, guys. Yeah, so guys, these are the values, are the outliers in between 88 to 39,000. These are the values, are the outliers. Okay, note this example. Hello. So guys, so you have one variable and an amount variable or an amount feature. So I'm just find the outliers with help of the jet score method. Okay. So with help of this one, you just figure out, in between 80 to 40,000, what are the data points we have it. Those are the data points we can call it as the outliers. Okay. I want to find the how many outliers are there. If you want to find the how many outliers, then simply we can use the length method. With help of the length method, we can find the how many outliers are there. Okay. Okay. Say it's a length. It's not length. Count. Why it is one? It's a shape. We need to find the shape, not length. So dot shape, okay, of 0. There is no shape. Okay. So outliers. Fine. Count length function only. Length of how you want. Okay, fine. Think I'm unable to play how many things. Okay, so this is the problem, guys. So if you want to know that how many outliers are there with help of this one, it's very tough to find out, but no problem. But generally, what I am trying to tell you, so in between the 88 to 40,000, these are the values we can call it as the outliers. Okay, so with help of the statistical method, we find the outliers. That means from the Z-score method. Okay, and second one is IQR, interquartile range. So interquartile range is, so in case of Z-score, it could be more than the 3 or it could be less than the 3, right? In case of interquartile range, then we are just find the quartiles, and if if any value quartile 1 minus of 1.5 into IQR. So you know that how we can calculate the IQR. Okay, so the formula for the IQR is Q3 minus Q1. Okay, this is the IQR, and so the values, it could be the less than the less than the so okay, if any value, it could be the less than the this value. Okay, if any value, if any value from your data frame, okay, it could be the less than the this value, or else if it is the greater than the okay, and IQR, oh sorry, Q3 plus 1.5 into IQR, 1.5 into IQR. Okay, so if any value, it could be the greater than this value, or if any value, it could be the less than the this value. Okay, those values we can call it as the outliers. Okay, so now I would like to go for calculating the outliers. So for calculating the outliers, we have to go for calculating the Q1. So how we can calculate the Q1, guys? So X dot, or else data dot amount. Okay, data dot amount dot quantile. Okay, quantile of 0.25. Okay, so 0.25 means 25% of the data. We find the quartile 1, and now I would like to go for find the quartile 3. How we can calculate the quartile 3 for the amount? So amount of, so quantile is the method. With help of the quantile method, we are calculating the 75% of the data. Okay, so this is the way we calculating the Q1 and Q2, Q1 and Q3. So from this one, we would like to go for calculating the IQR method, IQR value. So Q3 minus Q1, that we are calling it interquartile range. Now same method. Okay, so outliers, I would like to go for calculating the outliers. So the outliers are, if any value, okay, if any value AMT. Okay. Any value if it is less than the Q1 minus of 1.5 into IQR, right? Or this data amount. So or next data dot amount. So we are taking the amount and it could be greater than Q3 plus 1.5 into. Guys, this is standard formulas. I'm not doing anything. This is standard formulas. Okay. Dot any access equal to 1. IQR. Yeah. So let me go for print the outliers. So okay. Nothing is issue. No access named. It's a series, right? So I think you don't need it. Okay. Let me go for print the outliers. So these are the values are outliers, guys. So previously when I'm using the jet score, 88, 190, 194 also it could be outliers, right? Here, if I do this sort method, values. If I do that, if I do the interquartile range, in between 260 to 1490 values are the outliers. I think these are the indexes, I think 88. It's not indexes, it's the values on this. It's the values on it. Okay. Okay. Any questions? I think it's indexes, guys. This is indexes. Those are the indexes. Sorry, it's indexes. Okay. So these are the index positions. This is outliers. These are the outliers. Okay. And so if I do that sort, okay, fine. Okay. So these are the values are the outliers in case of Z score. In case of interquartile range also, it could, these are the outliers. Okay. So it's your choice. It's your task actually. So you need to make it the sort and then we can find actually. Okay. So with help of the Z score and with help of the IQR. So this is the two methods we can call it as the statistical methods. Okay. So with help of the statistical approach or statistical test, we can find the outliers. So of course, in our data, it is having the outliers at what quantity in the sense, approximately here we can see the length is 32,000. So we have the 40,000 observations are there. Out of the 40,000, 33,291 observations are the outliers. Okay. Any questions regarding about these two things? Now, we have the usual techniques. For the usual techniques, we have the two approaches. For usual techniques, we have the two approaches. One is the box plot. Second one is scatter plots. Okay. So this is the two methods we can just go and find the outliers. Okay. Let me try with the usual box plots and scatter plots. It's a very simple thing. So make sure that we need to import the matplot library or else Seaborn library. Okay. Let me import. I think I already imported, but for sake of understanding, so Seaborn. Okay. So import Seaborn as SBN or SNS. Okay, and meanwhile, we need to go for import the matplotlib also. In a matplotlib, we have the pyplot. So this pyplot we are importing as the PLT. Okay. So in Seaborn we have a method directly, or we have a method which is box plot. Okay, and we are taking the data is the data dot amount. So this is the variable we are taking, and we are just plot the show. Then it will be show that your box plot. Okay, so see, this is the box plot actually, and so from this particular box plot, so the values, it could be, these are the values or the outliers. Okay, so this line above and this line, this horizontal line, below this horizontal line and above this horizontal line are the outliers. Okay, so if you see this one, the values are from this range in between 252 or else 300 to 14,000 plus are the 1400 values are the outliers. So these are the outliers. With help of the visualization technique also, we can calculating the, or we are analyzing the, there we do have some kind of outliers are there in your data frame, in your amount variable. Okay, and second one is we have the scatter plot. So but for this particular scatter plot, we would like to take the SNS scatter plot data equal to data dot amount plot show. I think x1 by variables is required. Okay. See, most of the data it could be very close with this range. This range. Okay, most of the data thickness, right? The thickness it could be very high, but these are the values or the thickness is not good. Okay, thickness, the distribution, the scatter plots, it could be a little variation, right? So this each and every data point which is not close, we do have some kind of distance is there for each and every points. But when comes to this range, there is no gap. There is no gap with this range. So above this range, the values are distributed with somewhat thinness, okay, not in thickness. But below this range, the values are too much close. There could we do have some kind of thickness, high thickness. That means very close to each other. Every point it was very close to each other. So these are the values are the not outliers, and these are the values are the outliers. Okay, clear? Any questions? So how you are analyzing the outliers with help of this scatter plot? So the thickness of the scatter plots in the group. So based upon that one, I come to the conclusion. So there are outliers are there in my data set. Okay. And with help of the box plot, the line, the upper line, this thing we can call it as the upper whisker. And this line we can call it as the lower whisker. Okay. So upper whisker range and lower whisker line. So what the data points we have it, those are the outliers. Okay, with help of the visualization techniques, or else with help of the Z score, with help of the interquartile range, we can calculating the outliers in your data frame. Okay. So this is the main methods generally we use it, and in machine learning we do use other techniques also. Those techniques we'll discuss in a later sessions. Okay. Take care, guys. Bye. See you.
Thank you.
Thank you, Anjan.
Anshan, I have a question. So I'm new to the classes. Can I get the recordings of these classes? Will you provide the links?
Yeah, of course I can provide you. And can you please share me your mail ID to my WhatsApp number? Thank you.
Sorry?
You just share your WhatsApp. No, you just share your mail ID to my WhatsApp number.
Sure. Okay.
Okay. Thank you.
Thank you. All right. Bye.